Hey everybody, welcome back to another video within the Generative AI series, and in this video we'll actually be implementing what we have covered so far. So we have talked about cosine similarity, and if you haven't checked the video out, I'm gonna hook it up in the info card. Please go and cover that up before actually going forward with this video, because it's really gonna be helpful. And after that, we talked about what are vector embeddings and how they fit in within the world of vector spaces, and how it sort of forms a foundational concept within a RAG solution, which is a retrieval augmented generation. So before jumping into concrete and definitive RAG solutions, we really need to know what vector embeddings are and how they sort of help in terms of laying that foundation. So for this particular example, as we discussed in the previous video, that let's say you have a query or a word, let's say hello, and if you want to see and if you want your system to sort of recommend you the next set of phrases or the next set of words or sentences, then how can you sort of do that? So for this particular solution, we're just going to follow up with a very simple data set. I think it's the most simplistic data set. So we have hello world, hello universe, and what's up, how have you been doing, and stuff like that. So you get the gist of it. And we have a very simple query again. So it just says hello. So in this particular use case, we just want to know like which is the most similar phrase that we can get out of this particular data set. So the workflow would be that firstly, we're going to create an embedding out of our query. And we're also going to create embeddings out of this mini simplistic data set. And then we're going to apply the formula for cosine similarity. And I've also sort of covered it in more detail within the previous video, which was about vector embedding. So I'm also going to hook it up in the info cards. Please go check it out first. And after applying cosine similarity to it, we'll get a number. And then we just need to make sure that which one of these assigned numbers, cosine similarity numbers, we're going to pick the closest or the most similar phrase, which would obviously be something between 0 and 1. Everything beyond that, we're just going to ignore. Because as discussed in the previous video, if two vectors are perpendicular, then they're sort of unrelated. If the vectors are totally in an opposite direction from like a 180 degrees, if they have a 180 degree angle between them, then obviously, again, they're like in a very opposite direction. So we don't want to consider that. Everything between 0 degree to 90 degrees, something that we will consider between these vectors that we'll be generating. So let's go on and let's see what we have next. We'll be creating a function which would be about generating embeddings. Pretty simple. Uses OpenAI library and actually uses the model of text embedding 3 small, which is like does a decent job. We don't need anything super elaborative for this particular example. And right here, we actually create an embedding, and then I'm also using an NumPy library, which just converts this into an array. If you're accustomed with NumPy, or if you have some experience with machine learning, you know that this one is like one of the go-to libraries to actually evaluate your matrices or convert your lists into a matrices, convert your dictionary into a matrices. So it has a lot of utility function, really cool stuff. And then we have our function for writing the cosine similarity. Pretty standard stuff, totally follows the formula. Again, if you go on and see my video on cosine similarity, you will find the formula over there, and you'll find the description around how it works, what are the key things that we need to take care of or understand before moving forward. So yeah, that's covered there in a very decent way. All right, so we have, and again, you can see we're using NumPy dot formula dot function, sorry, in calculating the dot product. Then we're calculating the norm of these two vectors, which obviously be one vector would be the query itself, and the next vector would be uh, the phrases, one of the phrases from the data set that we have over here. So norm again is just like a way of calculating the distance or a length of a vector. And then we have the similarity formula over here, right? Perfect. Moving forward, again, we will be calculating the embedding for our query, and then we'll be creating a like a temporary array to store all the cosine similarities for all of our data phrases over here. And this is the for loop that actually traverses our data, generates the embedding for each item within our data, calculates the cosine similarity, the formula that we have sort of covered within this section, stores its value, and appends it in the array. Super simple stuff. Now, till here, we have the embedding for our query, and we have stored all the embeddings within our mini data set into this particular array over here. So we have everything in place. So all we need to know now, like which are the values or which are the phrases that suit us the best. So again, if you've used pandas and you know about data frames, so it's just again a very great library to deal with matrices and creating data frames. It's like a good representation of matrices as a data table, and this particular library really does all the operations for you, and it's kind of really easy. Again, if you're from a machine learning background, you would know how handy these two libraries are. So we create a data frame. The very first column is basically the data, and we're just calling it text. So it would actually represent these text within the very first column. And in the second column, we would like to hook up all the cosine similarities. And this here again is just printing the data out, just like in a decent way. Then we're just going to print out some of the top similar values over here. And to do that, what we're using the data frames lock function. It's a functionality where you can actually locate the location for a particular index, and we're hooking up these indexes over here. So these indexes would obviously represent to the n largest. And when I say n largest, it's obviously it's gonna show the data frame from largest to the smallest, and then we're just gonna select the top two of them, or you can actually change it to 3. But in our case, since our data set is pretty simple, so I'm just for the sake of representation, I'm just gonna choose 2. We can even choose 1, but I think 2 is good. So this here would give us like a very good representation of what we want. So yeah, let's get into it. Right, I'm just gonna run it real quick, and all right, it's gonna take its time, and there we have it. We have uses sentences, and you can see it has actually represented all of it into a pretty nice looking data frame. So we have hello world 0.587. Obviously this one seems the highest. Then we have hello universe 0.47, 0.44. And you can see that the only relevant ones, since our query is hello, only the relevant ones are of the highest scores. And hence they actually indicate that these are the most similar ones. So that's the whole concept over here. And we choose the top similar ones is hello world and hello universe, and we can do some stuff over here to actually break the whole sentence down and give us the recommendation for each token. And then we can select each token and we can go on from there. So just for the sake of experimentation, let's change our query to somewhat like what? Let's see what the result is. So now you can again see like the most similar ones that we are getting is hello world for some weird reason. And yes, this is one problem with the vectors is like when we're actually determining the similarity, then sometimes the context of it can actually, you know, not be relevant. Just like in this case here, we are getting what's up and it's like the most appropriate solution. Uh, it has like almost the same value as hello world. So that's the gig over here. Let's see another word, and we can say something like how have. Let's see how this shapes up. Whoa. And now that we have hello universe again, but for what it's worth, we get what's up, how have you been doing as the top similar sentence and phrase. So this is the whole concept about vector embeddings and how they work in a in a in a RAG solution. Obviously, if you have a document or if you have a PDF, you would be converting them into strings, which would consist of like thousands and hundreds of phrases, and you can go about determining their similarities, and you can sort of that's how you can find a particular phrase within a PDF. So that's the whole concept of it. So yeah, we'll be talking more about RAG in the upcoming videos. I hope you like this video, and we talk about generative AI solution and on this channel, and we talk about a lot of tech stuff on this channel. So if this interests you, hit the like button, hit subscribe, and thank you for watching.